Problem 5. Use the expression below to answer the question that follows. Okay, there's my expression, and here's the question that follows. Which of the following is the best estimate of the value of the expression above? So when they want best estimate, it's really just saying, look, you don't have to do all of the math. Just kind of round out everything and try to figure out what this is saying. So if I wanted to round this out at the 32,629, I'd say that's approximately equal to 30,000 times, instead of 484, I'm going to say that's roughly equal to 500. And then divide that by 306,751. I'm going to say that's roughly equal to 300,000. So the first thing I want to do, maybe I'll divide the top and the bottom by 3. So this 30,000 will become, let me do it in darker color, will become 10,000. And this 300,000 will become 100,000. 100,000. And then I can start canceling out zeros. If I divide the top and the bottom by 10,000, I can essentially get rid of 4 zeros on the top and the bottom. So then this 10,000 divided by 10,000 will just become 1. 100,000 divided by 10,000 is just 10. That just becomes 10. And then we're left with 500 divided by 10. We can just cancel out some more zeros. Can divide the top and the bottom by 10. You get a 1 in the bottom, and you get a 50 on top. So you can say this is roughly equal to 50. And lucky for us, that's actually one of the choices. Problem 6. Use the diagram below to answer the question that follows. The measurements in the diagram above are shown rounded to the nearest whole number. Which of the following is a possible value of A, the area of the rectangle? So what they're saying is that these numbers, these aren't the actual values if we were to be precise about it. They just rounded them to the nearest whole number. When you just multiply these two things to figure out the area, you get an area of 8 inches or 8 square inches. But when you look at the choices, I don't see an 8 square inches. It seems like it's either going to be B or C. And if you just look at these two numbers, which one's closer? Let's see, 8 to 5.5. So 8 minus 5.5. That's what? 8 minus 5 is 3 inches. So this is 2.5 inches. So we're 2.5 inches from this one. And we are 3.5 inches from this one. So if I was stuck for time, I would go with this one. But just to verify that this definitely could be an answer, if these are rounded to the nearest whole number, then this one could be as low as 1.5 inches, right? If this dimension is actually 1.5 inches, when they rounded it, they would have made it 2. It couldn't have been 1.49 because then they rounded it down. Similarly, this could have been as low as 3.5. When they rounded, they would have rounded it to 4. It couldn't have been 3.49 because then they would have rounded it down to 3. So if this dimension was 3.5 and this dimension is 1.5, what would the area have been? So 3.5 times 1.5. See, 5 times 5 is 25. 3 times 5 is 15. Plus 2 is 17. Put a 0 down. 1 times 5 is 5. 1 times 3 is 3. 5. 7 plus 5 is 12. And then you have 1 plus 1 plus 3 is 5. You have two numbers behind the decimal point, 5.25. So the minimum possible area for this rectangle is 5.25. That's the minimum. So 5.5 is definitely a valid answer. So I'm going to stick with my answer B. Next problem. All right. Use the table below to answer the question that follows. Okay, they have a store, different stores, discount for manufacturer's recommended price. Okay, there we go. So they're all discounting games. Samantha wants to buy 2 computer games, each of which has a manufacturer's recommended price of $20. She checks 4 different stores and finds the prices of the games discounted as shown in the table above. At which store will Samantha be able to buy the games for the least amount of money? That makes sense. You want to find the cheapest place. So this is $4 off the price of each game. Remember, she's buying 2. The manufactured price is $20. So she's going to pay $4 off of 20 for each game. So she's going to pay 16 plus 16, which is equal to 32. That's at store number 1. 30% discount on each game. So 30% discount, so $20 times 30% discount is 0.3. So so you can imagine 3 times 20 is 60, and then you put the decimal sign. It's going to be a $6 discount on each game for this one. So $6 discount, remember 30% of 20 is $6. So $6 discount will be $14, right? 20 minus 6 per game that she buys. So she's going to spend $28 at store number 2. We switch colors. 1/3 off the price of the 2 games. Well, you could immediately say that 1/3 is 33%. So that's a bigger discount than this one. You could do the math. You'll figure out, instead of this being $6, it'll be $6.66, and this is going to be $13 and something something plus $13 and something something, and you're going to get something, $27 and some change. But you know that this is a better deal than this one because this is the same thing as 33% off, which is clearly better than 30% off. And then the fourth one, buy one game and get the second at half price. So here she's going to spend $20 on the first game, and then the second one is going to be half price. So she's going to spend a total of $30. So the best deal is store number 3, where it's going to be 27 something dollars, right? I mean, store number 2 is definitely better than store number 4, which is definitely better than store number 1. And then store number 3 is definitely better than store number 2. It's a 33% discount. So I'm going to go with store number 3. Next problem. Go to the next problem. 8. Use the procedure below to answer the question that follows. Okay, n is equal to 0.63. Okay, 100n is equal to 63. So they just multiply it by 100. Okay, they're trying to eliminate the repeating decimals. I get it. The procedure above shows how to convert a repeating decimal to a fraction. All right. If 0.12561256 is a decimal with 4 repeating digits, which of the following represents this decimal as a fraction? So what you do, we'll just do with the procedure we did before, and this might bring you back memories from algebra class or pre-algebra class. Forget when you first learned it. You say n. Or we could just do exactly what they did there, is equal to 0.1256. And then we could multiply that, and you could even pattern match. Here we had 2 digits repeating. They multiplied it by 100. And 100 has 2 zeros. Here we have 4 digits repeating, so we're going to multiply it by something with 4 zeros. So we'll have 1, 1, 2, 3, 4. There's our 4 zeros, so that's 10,000. N is going to be equal to what? Well, what's 0.1 of 10,000? It's 1,000. What's 0.02 of 10,000? I think you get the idea. It is 2,000. Sorry, it's 200. So you get 1,256. 0.1256. It just keeps repeating on and on and on. You get the idea. We just multiplied this by 10,000 because that allowed us to bring one whole repetition to the left of the decimal. You could verify it. Actually, let's multiply it out just to verify that this actually works. If I multiply 1256 times 10,000. What you can do is you can just multiply it by 1. So you get 1256. Add 4 zeros, 1, 2, 3, 4, and then count how many decimal points you have. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we verify that it works. Now, of course, I didn't multiply the entire repeating part. If it just kept repeating, then we'd have a 1, 2, 5, 6, and they'd keep repeating, so on and so forth. But you saw it worked in the pattern, and it works here. So once we get that, we just essentially want to subtract this guy from this guy. So we say minus n, or you could say this is equal to minus 0.1256, and we are left with, on this side, what's 10,000 minus 1? Well, that's 9,999 is equal to, well, when you do the subtraction, this and this part are going to cancel out. The decimal parts cancel out, and you're just left with 1,256. So 9,999n, remember there's a coefficient there, I don't want to lose that, is equal to 1256. Or if we divide both sides by 9,999, you get, so n is equal to 1256 divided by 9,999. And that is one of our choices. 1256 divided by 9,999.